Okay, thank you. Okay, so yesterday we have discussed about the two-dimensional conduction, so we will continue our discussion with some examples. Okay, so just a recap. Yesterday we have discussed about the energy balance method. So we solve for the temperature distribution using this method. So we also apply the finite difference equation or finite difference approximation to the temperature gradient at the boundary between the two nodes. So the remaining conduction rates are also expressed. So we also studied the temperature distribution at different cases. So we have actually five cases. Case one is for interior node. Case two is for node at an internal corner with convection. Case three is node at plane surface with convection, and case four is node at an external corner with convection. While case five is node at a plane surface with uniform heat flux. Can you recall if you already answered this example problem yesterday? Have we done with this?
Hindi pa po ata. Hindi pa po ata.
Hello po, sir. Hindi pa ata po. Hindi pa po.
Okay, thank you. So we will discuss this today. Okay, so using the energy balance method, derive the finite difference equation for Mn nodal point located on a plane, insulated surface of a medium with uniform heat generation. So network of nodal points are joining an insulated surface. So as you can see here in our screen, we have a figure wherein the other side is fully insulated surface, while the other side is exposed to, so there's no fluid, so there's only conduction. So the other side is conduction. Okay. So based on energy balance, energy in plus energy generated is equivalent to zero. So we will just uh, quant s- sum up all the energy coming in plus the energy generated. So you have one, two, three, four heat transfer coming in into this nodal points into this network. So we have Q1, which is from node M minus 1n, Q2, which is from node Mn minus 1, Q3 from node Mn, Q4 is from node Mn plus 1. So just to have, we'll just have to add this for heat transfer rate. So these are the energy coming in. So as you can see, this is insulated part. So there is no heat transfer here. So Q3 is equivalent to 0. So we only have 3 heat transfer. So that we will add 2 heat generated. So this is our equation. Q1 plus Q2 plus Q3 plus Q4 plus Q of heat generated, which is equivalent to the Q times the volume. So using this figure, our volume is area times height, which is delta x over 2 times delta y times 1. Since we are dealing with conduction, we don't have any value for z. So yeah, you just have to use the Fourier's law for quantifying the heat transfer. For the x direction, we have k multiplied by the area. So the area here is for the Q1. So the area here is delta y times 1. So for Q2, Q2 is coming here from below. So the area is delta x over 2 times 1. So that's why we have here delta x over 2. And then Tmn minus 1 minus Tmn. So this is our delta T. Tmn minus 1 minus Tmn. And then we have for Q3, as I have said, so there's no heat transfer here because it's fully insulated. So Q3 is equal to 0. For Q4, we have here same as Q2. So the only difference is that the nodal temperature location, which is Tmn plus 1. So we have Tmn plus 1 minus Tmn as our delta T over delta Y. Okay, so when we all have these equations, we can now add to obtain the temperature distribution equation. Just add this 4 equation and include the equation for the heat generated. Okay, so going back, if we already add this, we will obtain this equation. So where does this 40 mn come from? So as you can see here, we have 1, 2, 3. Okay, so our equation is 2m minus 1n plus tmn minus 1 minus tmn plus 1 minus 40mn plus q delta x times delta y over k equals 0. So yeah, we just have to add all these equations and then include the heat generated. So this is our heat generated. Okay, so this is what is asked in the problem. So if you already derive this, so it's okay. It is considered as the final answer. But if in case there are some information provided, let's say you are given different temperatures. So let's say we have A, B, C, and E, D, and E. So we have temperatures for that. Also, we have temperatures for the fluid. So what you will do is you will just substitute these temperatures to the equation. So this equation, for example, Tm minus 1n. So this one, Tm minus 1n. So the temperature here is Tb, which is 227.6. Next is Tmn minus 1. So the temperature here is Te, which is 222.4. Next is Tmn plus 1. Tmn plus 1. So this one. Given temperature here is Ta, which is 235.9. Okay, so we also have T infinity, which means there is moving fluid here. So you will add convection heat transfer into the equation. So that's why we have here but in this case, it's not considered. Hmm? Okay, so it's not considered here. So in this equation, but actually, if there is some convection coefficient, so we have to apply this. So we have to include the uh, heat transfer. Or the reason is that in energy balance, so this is our considered as the region. So by using energy balance, they did not consider this fluid coming outside. So that's why there's no heat transfer for convection here. So but in other scenarios, so we include convection heat transfer. Okay. I think I already sent this lecture to you yesterday, right? In the Google Classroom. Okay, so do you have any question regarding this problem? Okay, so if none, so we will proceed with our next sample problem. So a large industrial furnace is supported on a long column of a fire clay brick, which is 1 meter by 1 meter on a side. During steady state operation, installation is such that three surfaces are of the column are maintained at 500 Kelvin, while the remaining surface is exposed to an air stream for which T infinity or temperature of the stream is 300 Kelvin, and the convection coefficient is 10 watt per square meter Kelvin. So using a grid of delta x equals delta y equals 0.25, determine the two-dimensional temperature distribution in the column. Use Gauss-Seidel iteration and matrix inversion in determining the temperature distribution in the column. So in this problem, we will use the Gauss-Seidel iteration and matrix inversion to determine the temperature distribution in the column. So first, we have to write or create the figure for you to be able to understand it better. So as shown in the problem, there is a 100 by 1 meter by 1 meter fire clay brick. So ibig sabihin, di-divide natin. So which means that we will divide the 1 meter by 1 meter into 4 because according to the problem, using a grid of delta x equals delta y equals 0.25, meaning delta x is 0.25. It's 1/4 of the figure. So you have to divide it by 4. Okay, so divide it by 4. Yeah, so we have now delta x and delta y. So let's put some direction. So we have here delta x. delta y. Okay, so now we have delta x and delta y, and also in this figure, so it is given that there is a 500 Kelvin temperature of the surface, or three surfaces. So we have to include 500 Kelvin. We have to show 500 Kelvin. So we have here Ts equals 500 Kelvin. Okay, so it is three sides. Okay. So additionally, there are some information on the fluid coming on this direction. So we have here if air, which is 300 Kelvin. So there is a convection on this part, on the bottom of the plate or the column. So we have here H. Okay, so now, okay, so that's our figure. Okay, so now we will put the nodes. We will number each node, so we have to put some nodes here. Okay, so yeah, as you can see, we have interior nodes here. So let's label it one. So 1 to 8. Okay, so it is asymmetrical figure, so you just have to copy this to the other side. Okay, so that's our figure. So that's our figure. Okay, if you have any question, you can butt in anytime. So you can interrupt anytime. So as you can see, node 1, 3, and 5 are interior node. So which means that we will use the equation for interior node. So this equation is case number 1 for interior node, okay? Case number 1. So and this is case number 1. Okay, so let's evaluate. Let us put all the temperatures in the nodes. So let's begin with node 1. Okay, node 1. So this is node 1. And what are the neighboring nodes? By following this formula, so which is Tmn plus 1. So Tmn plus 1 is above 1, which is 500, above T1, which is 500 Kelvin, plus Tmn minus 1, Tmn minus 1, Tmn minus 1, so below T1, which is T3, plus Tm plus 1n, so it is 2, T2, plus Tm minus 1n, also 500, minus 4 Tmn, which is T1, T1. So that is our working equation for node 1. Did you get it right? So we can simplify it as T2 plus T3 plus 1000 minus 41 equals 0. So let us remove 500 here. Okay, so yeah, that's our node 1. Question? Can you follow? So for node 2, the neighboring nodes are, yeah, Okay, so node 2. Let's proceed with node 2. So we have the neighboring nodes 2T1, 2T1 plus T4 plus 500, which is above 2 plus 500 minus 42 equals 0. So it is, meron pa siya, it has also equivalent to 0. It is also equivalent to 0. Ah. So next node 3. Node 3, so we have uh, T1 plus T4 plus T5. So T1, T4, T5 plus 500 minus 43. So node 1, 3, 5, node 1 to 6 are interior node 1, 1 to 6. Okay, so let's proceed with node 4. So we have T2 plus 2T3 plus T6 minus 44 equals 0. So we don't have value here. Okay, so that's our node 4. Then node 5. So this is our node 5. So the neighboring uh, nodes are T3, T6, and T7 plus 500 here. So we have T1, ay sorry, T3 pala. T3 plus T6 plus T7 minus 45 so plus 500. So Plus 500. Okay, so that's our equation. So next we have node 6. Node 6 is here. So we have 2T5 plus T4 plus T8. 2T5 minus 46. Okay, so that's our node 6. So node 7. Okay, so can you double check if what we are doing is correct? I'm arranging it so that it will fit. 7 and 8 will fit this. Yes. Hello?
Sir,
Mm-hmm.
clarification lang po. Meron po ba
Mm-mm.
talagang plus 500 dun sa Node 6 po?
Node 6. Ay, wala. Sorry. Node 6. Wala po. So, it's a typographical typo error. Thank you for clarification. Okay, so next, node 7. So, node 7 is node 7 and 8 are at surface with convection. So, node 7 and 8 se- are at surface with convection. So here we will use a different equation which is uh, case 3. Case 3. Which is case 3. Yeah, this case 3, however, the location will be different because in node 7 and 8, so the fluid is located below. So there will be some rearrangement on these equations, but it's all overall, so it will be our working equation. So node at a plane surface with convection. Going back. So it does. Okay, so this is node 7 and 8. Okay, so node 7 is you have 2tm minus 1n. Okay, so we'll have so 2t m plus 1 2tm n plus 1. So we have 2t5 plus plus 500. By the way, we use delta x for convection, right? So in this equation, so 2h delta x. Wait, I will enlarge it. So the value, so the value of 2h delta x times t infinity is, so we have 2h delta x over k is 2 times 10, h is 10, delta x is 0.25, and k equals 1. So k, let's put it here. Uh, k equals 1.0 watt per meter Kelvin. So let's assume that k is 1.0 meter watt per meter Kelvin. So 2 2 times h, which is 10, so 20, sorry, 2 times h, which is 10, times delta x, which is 0.25, so over k is 2.5, or 2 times 2.5. 2 times 2.5 is 5, times 300 is 1.5. So plus 1.5 minus 2 times 2.5. This the value of h delta x over k is 2.5. So 2 times 2.5 plus 2 is 2 times 9. So we have 4, we have 9t 7. Okay. So that's our node 7. So for node 8, we have, this is our node 8. So 2 times tm, 2 times tm n plus 1 is 2 times T6. 2T6 plus 2 times uh, T7 2 T7 plus 2T7 plus 1 5 1 5. So why 1 5? Because of 2 times h delta x, which is 2.5. So 2 times 2.5 is 5 plus I multiplied by 300. So 2 times 2.5 times 300 is 1 5 minus 9 T8. So that is our equation. So we will rewrite now this equation for us to be able to use the inverse matrix method. So let's delete this first. So I'll just copy this na lang. Okay, so let us rearrange this equation. So according to T1, T2, T3, T4, T5, T6, T7, T8. So for us to be able to get the matrix, so first equation, so we have here 41 negative. So we have to rearrange it for uh, in accordance with the node. So we have 41, negative 41. We have T2, right? Okay, I'll just delete this first. So we have negative 41 plus T2. We have T3 plus T3. We don't have any T4 here plus. So we will leave it as 0 plus T5. We don't have T5 also. So 0. So we will put 0. T6 we don't have also, as well as T7. Sorry, T6 0, T7 0, and T8 0. So yeah, that's our first uh, equation. So next is, so for node 2, please kindly double check if what we are doing is correct. So I forgot to include the 1000 here, negative 1000. So see, this is negative 500. So we don't have any, we have 2T1, 2T1 minus 42 minus 4T2. T3, we don't have T3, right? So we don't have T3. T4, we have T4. Okay. We have T4. T5 we don't have. T6, 7, 8. Okay. Okay, so node 3. So we have T1, T2. We don't have T2. Why it's 2 T4? Dalawa yung T4. So what's correct here?
T5 po.
T5. Ah, okay, sorry. So T5. Okay. So yeah, so we have T1, T2. We don't have T2. We don't have T2. T3, we have T3, minus 4 T3. Plus T4 plus T5. So we don't have 6, 7, and 8. Okay. Okay, next is node 4. So node 4, copy. Let's copy this. So this is 0. So we have don't have T1. So 0. We have T2, yes. T3, we have 2 T3 positive. T4, 1 negative. T5, no. T6. Then T7 and T8, we don't have value. Yeah, that's our node 4. So next, node 5. So mid, we have we don't have T1 and T2, right? So 0. T3, yes, we have T4, we don't have. T5, we have negative 45. So we have T6, T7. So yeah, that's our for node 5. Next, node 6. Oh, by the way, there is a negative 500. So you should check. We don't have also. Okay, so we have T1, no T1, T2, no T3. So, but we have T4. And then T5, we have two T5. T6, we don't, for T6, minus 4 T6. T7, we don't have T7 here, but we have T8. T8. Is that correct? Okay, last, not last, but node 7. Node 7, we have no T1, T2, T3, T4, but we have T5. 2 T5 plus T6, we don't have. So we have negative 9 T7, 9 T7, and we have T8 as well. So this is negative 2000. Let's combine this 515 to 2000. Okay. Last but not the least, node 8. Node 8 is 2T6, 7, 8. So we don't have 2T5. We have 2T6, 2T6. We have 2T7. Uh, minus 98 equals negative 1500. Yeah, so, okay. So that's it. That's our equation. You have any question? Is this correct? Can you double check? Okay. So yeah, that's the purpose of arranging this equation is that for us to write it on the matrix. So let's double check. So this is our matrix. So in an instant, we can create a matrix. So yeah, so we have negative 4, negative 4, 1, 1, negative 1000. Okay, so 2, negative 4, 0, 1, and then the rest are 0, and then we have negative 500. Okay, so 1, 0, negative 4, 1, 1, 0. Then 0, 1, 2, negative 4, 0, 1, 0. Wait lang. So, node 4. 0, 1, 2, negative 4, 0, 1, 0, 0. So, it's correct. 0. Next is node 5, 0, 0, 1, 0, 0, negative 4, 1, 1. Okay, negative 500. Node 6, so we have three zeros, 1, 2, and 3, and then T4 is 1, 2, negative 4, 0, 1. So it's correct. Node 7 is 1, 2, 3, 4 zeros. So 1, 2, 3, 4, and then 2. Then followed by 0, followed by negative 9, followed by 1. Okay? And lastly, we have 0, 0, 0, 0, 0, 2, 2, negative 9, negative 1, 5. So it's correct. So from here, you can now solve for the value of T1. Okay? You're using inverse matrix, using matrix inversion. So I will put here the correct value to be able to work on your own. So this is our value. So you can double check if your solution is correct. So I'll just put it here. Yeah, this one. So this is what we are looking for in this problem. So the value, the temperature distribution of uh, the temperature distribution. Okay. So we have T1 up to T8. So yeah, that's our final answer. Okay. So do you have any questions? Okay, so we have another example here wherein you can, yes, Alvin,
Sir, excuse po.
uh,
Pwede kaya pong pabalik sa slide 55? Mag-screenshot lang po. Thank you po.
55. Uh, this one?
Yes po, sir. Sir, dyan
Okay.
po pala sa nasa table, paano nyo po nakuha yung 1, 2, 1, 3, 4, 3, 5, 6, 5, 7, 8, 7 po?
This table, this numbering.
Yes po, sir.
Okay. So we will start with interior nodes. So we just have to number is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. So however, it's identical. So this 1, 3, 5, 7 here is identical to 1, 3, 5, 7 on the right. So because it is symmetrical. Yeah. If there is a symmetrical configuration, so you can write as is as same as this. So yeah, it's identical. 1357 here and 1357 here. Okay.
Ay, sir, paano po pag ang case po ay hindi identical? Paano po kaya?
If it's not identical, so you have to write another number here. So you will have a different interior nodes. So maybe a larger nodes, like up to let's say more than 10. Yeah. So the numbering will
May
vary.
example po kayang ganun?
Hello? Yes?
May example po kayang ganun, sir?
Usually, in this case, we are dealing with square, square because delta x equals delta y. So I think there are rare cases wherein it's not identical because we are dealing with delta x equals delta y and it is always square. Yeah. So, but I will try to find in your problem set. I think there's none. Let me check. Yep. Yes. Another question.
Tapos po sir, last na po. Do'n po sa node 3 po, 'di ka po ay may dalawa po tayong node 3. Yun
Mm,
pong isa
yes.
ay yun pong malapit po do'n sa outside po. Ayun pong 'di ka po ay do'n po sa isa, do'n po sa may baba ng 1 from left side po, 'di ka po ay naging node natin do'n ay P1, P4, node 3. P1, P4, P5 plus minus 3 T3 po. 'Di ka po ay may 500 po yun 'pag yun pong nasa left side. Ay 'pag po yung sa right side po tayo nag-base, may plus 500 pa rin po kaya yun?
Wait, let's see. So you mean okay. So you mean this node 3,
Yes
T1
po,
plus
sir.
T4 plus this is T5.
Opo, T5 po.
T5. Okay. T1 plus T4 plus T5. So there's 500 here, yeah, right? So, and you mean the other node, the other side, this one?
Yes po, sir. Kung 'pag diyan po nag-base, eh, may plus 500 pa po.
Okay. So, but here, node 3. So, but we are, this is only based on this, this part. Yan. So, only this part. So, that's why there's only 1,500. Right? So, but if you will base here on this part, so you will not you will not sum up 500 plus 500. So, is that what you're asking? So, you mean we have to add 500 both?
Sir, I mean po, sa isang 'di ka po yun pong parang tree po sa left side, parang exposed nga po siya dun po sa kabilang temperature po. Ay ano pong isa 'di ka po ay parang
Mm.
may isa pa pong block before pa po mag-expose sa temperature. Yun po ang ibig kong sabihin. Bale hindi na po siya
Ah,
magfa-500 plus 500 if magiging affected
yes.
po siya.
Yes, we will not consider 500 here because there is still huh? Yeah, we will not consider 500 here. So because there is still uh there is still another node here, you mean? So yeah, we will only consider this side 500 on this side only, on the left side. So we will not consider the right side.
Sir, bale po ang mostly pong gagamitin or ang lagi pong gagamitin ay yun pong side po na malapit po sa
Sa fluid.
base po.
Ay sorry, sa outside.
Opo, yun po lagi
Malapit
ang
sa outside.
gagamitin.
Yes, yun
Okey
po.
po. Thank you po, sir.
Yep. So I'll try to find another example wherein it's not symmetrical. Yes?
Sorry, Paul. I don't know. I understand from because node one T3 plus T2 plus 1000,
Mhm.
then minus 41. Why the
Mhm.
41, Paul?
Yeah, because of the formula. So this is our equation. So this is a intermediate case 1. So the equation is Tm n plus 1 plus Tm n minus 1 plus Tm plus 1n plus Tm minus 1n minus 4Tmn. So Mn is T1. So that's why we have 4T1.
Okay.
So for,
Paul.
yeah, is that what you're asking?
Yes, Paul. Then what about
Okay.
the 97 and 98, Paul?
Yeah, because we have here equation is this one. This one. So this is for case 3. So the value of 9 is from here. So we have 2 times h delta x. H delta x over k is equivalent to 2.5 because the value of h is 10. The value of delta x is 0.25. The value of k is 1. So we have 2.5 here, the value. Let's put here. So this is 2.5. 2.5. Yeah, so 2.5 plus 2 is 4.5. 2 times 4.5 is 9. So
Yes,
that's
Paul.
why we have 97.
Okay.
97 and 98. So this is for the nodes that are near the convection because there are air moving here. So
Okay, Paul.
this will be our working equation. Okay.
Yes, Paul.
Okay. Thank you. So do you have any more questions?
Indeed. Thank you, Paul.
Okay. So yeah, I think you are already prepared for your midterm exam coming October 16. So hopefully you are solving some of the problems that I provided to you. Okay, so aside from this example, I also prepared another problem like this problem. So I think I found another problem wherein it's not symmetrical. So 1 to 9. So you can also solve for this problem. So I think this is what uh, Alvin is asking earlier. So consider the square in figure. So the left face is maintained at 100 degrees Celsius and the top face at 500 degrees Celsius, while the other two faces are exposed to an environment at 100 degrees Celsius. So H equals 10 watt per square meter degree Celsius and K equals 10 watt per meter degree Celsius. So the block is 1 meter square. Compute the temperature of the various nodes as indicated in figure and the heat flows at the boundaries. Okay, so for your convenience, I will put the solution here so that you just have to study. But since we do not have enough time, so I will put the solution here. So this is from, I think this is from other references from Holman. So the nodal equation. So nodes equation. So this is the equation for internal node that we have discussed before. And then sorry. I need to provide a new slide. Yeah. So the equations node 3, 6, and 7 So for your convenience, I will put here because we do not have enough time to discuss. So you'll just have to study how is it how it was solved. And this one. So this is our final answer: node and temperature. Okay. So kindly also study this one. So I will save it for your use, for your future use. Yep. Yes. Up to this two-dimensional. Okay. Okay. So yeah, I will post it on your Google Classroom. So I think I have to delete this one. I'll just save it. Save as. Okay, so please wait. I will upload it on the Google Classroom before I forget. So 3107. I will just edit what I have posted yesterday to include this example. Okay, so it's already posted now, so you can check your some of the examples that we have just discussed. So do you have any questions? So if you don't have any more questions, so let's see each other again next time, next week after exam. Thank you.
Thank you po.
Thank you po.
Thank you po, sir.
Thank you po, sir.